the 0. For 1, because there's a 1 bit, so we're going to return 1. For 2, there's also 1 bit, because it is 1 0, so we're going to return 1. Yeah. So first of all, let's just try to solve it in brute force. So for I in range n plus 1, and we're gonna prepare an answer array, and the answer array gonna append I dot, we're gonna use a bit count in Python. Yeah, so we're gonna append the bit count, and finally we're gonna return the answer. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. And the time complexity for this problem is n log n maybe. So n gonna be on this number, and yeah, the log n is this value, 10 to the power of 5. Yeah, so the time complexity, we're gonna say it n log n. Now, can we optimize it to, yeah, so this is the n log n time complexity. Can we do it in linear time? Yeah, maybe a single pass. Can we do that? Yes, of course. And basically, we're gonna use mathematics skills, because you know, for a number, for example, for number 2, it is 1 0. What about number 4? It is 1 0 0. Yeah. So the only difference is if it is number 2, the 1 bit is 1, and for number 4, the 1 bit is also 1. What about number 8? It is also 1. Yeah. So in this way, we can find some properties. So for example, number maybe 6, it is 1 1 0. What about number 12? It is 1 1 0 0. So the only difference is there are more 0, but the number of ones is the same. This means we're gonna use dynamic programming to solve the problem. Yeah. So if this is an even number, and for the next number, so for example, if this is an even number, for the next number, if it is the 2 times of this number, for example, it is 4 8, 2 times of this number, so definitely the number of 1 bit is the same. But if this is an odd number, for example, if it is 3, yeah, how can we calculate this odd number? So we're gonna check it with number 1. Yeah, so this is number 3, we're gonna check with number 1. Number 1, there's only 1 bit, but the difference is that if it is number 2, it's gonna be the same. There's gonna be only one bit. Yeah, but if it is an odd number, we're gonna need 2 plus 1. So this means 1 plus 1, it's gonna be on 2. So the number of 1 bit is gonna be on 2. This is the only difference. Yeah. Now let's just start on dynamic programming. So we're gonna prepare f gonna equal to, let's say 0 times n plus 1, and we just need to use a for loop. So for I in range from 1 to n plus 1, and what is the number of for I index, so fi gonna equal to fi divided by 2. So if I modulo 2 equal to 0, else it's going to be fi divided by 2 plus 1. So this is going to be the fi. And finally, we just need to return the f. Yeah, so this means if the index is odd, basically we need to plus 1. I divided by 2, we need to plus 1. If it is even, it is okay. We just need to divide it by 2 to find where it is. Yeah. So let me just use the first example. Yeah. So from the beginning, we're gonna set this one as 0. So first of all, this is odd. So 1 divided by 2, it is 0 plus 1, it is 1. And for this one, as it is even, the index is going to be 2, I equal to 2, 2 divided by 2, it's going to be 1, it's going to be this number. So this is why it works. Now let me just run it to check if it can pass. As you can see, it passed for all testing cases. Yeah, and the time complexity for this problem is going to be O(n). And because we just used one loop to solve the problem. I know it's going to be a little bit slow for testing cases. As you can see, now it works. Yeah. I think that's all about it. Thanks for watching. See you next time.